Hi, today's tutorial is going to be on how can you acquire an analog signal, convert it to digital, and then send that data to your laptop, running Julia. We are going to process it and plot it in real time as well on a web page. For this project, we are going to acquire data with an Arduino microcontroller board that will connect to a PC running Julia, where we will route the signal to a website created using Genie Builder. For this project, we then are going to use a microcontroller. It's not very different from a normal CPU that you will find, for example, on your smartphone, but the chip itself has more adequate peripherals for the usage on small embedded systems. One of these peripherals is an ADC, an analog to digital converter that can't be used to acquire analog data. On our project, we are going to use an Arduino board that I will show in an instant, where we have the microcontroller that will connect through USB to a laptop and we'll program it on C, and also we are going to use that communication to send our converted analog data. The communication is done through USB, but it's actually simulating a serial port. This is pretty useful for us because it can be easily interfaced on Julia. We will get that data coming from the USB, plot it on a web page, and we can use that web page to access that data anywhere on the world. Now, an Arduino board got everything that you need to start working with a microcontroller. That microcontroller not only has the ADC that is going to acquire our data, but also has memory and other peripherals, as for example the serial port circuitry, are also on chip. These type of systems are quite cheap to produce, low power, and easy to program. While they can have an operating system, it's not unusual to do bare metal programming directly on the hardware, as we are going to do today. And for that, we'll be writing a small C program that will be compiled on assembly and programmed on the microcontroller. We will use the microcontroller ADC to sample an input voltage on a pin that we will then define. The input voltage needs to be between the microcontroller supply voltage. We are going to use the USB connection as a power supply. So in our case, we are going to be limited from 0 to 5 volts. If you inject an higher voltage, then you are going to saturate the ADC that will either malfunction, burn, or give you the peak value of 5 volts. The data is periodically stored on a memory register that we will read and then send that data to the PC. So the microcontroller will read the ADC data and send it to the serial port on the PC. The serial port connection, it's either simulated on a different chip on the Arduino board, or it can also be done on software. The operating system on your PC will recognize that it's connected to the Arduino board through a simulated serial port and will be able to read the data in a similar fashion as it will be reading a text file by reading lines of strings. We will then write a Julia code that will pick up that data and plot it using the plot library first. After confirming that is functional, we will use the Genie Builder GUI to create a web page with a single plot that is updated in real time with the data coming from the microcontroller. The plot, it's going to be interactive, and also it's going to be updated as soon as we get some new data coming from the ADC. So let's first start with the Arduino part. I'm going to search for Arduino download, and we can go to the Arduino website. Go over here for the latest version of Arduino. Here on the right, you got different versions for each operating system. I'm going to select Windows. This is the one operating system that I'm using. Here you can click and contribute, or you can download, and then click again, just download. You will now download the Arduino IDE. This is the application that we are going to use to write our program and then program the microcontroller on the Arduino board. So we can go ahead and run the binaries. So this is the license part, you can accept, next, and then you just click install. I'm not going to install, I already have it on my computer, but you just need to click it and let the program install. Once you open the Arduino IDE, the following window is going to appear. Let's wait a bit. Here it is, with two different functions, one here on top to set up your microcontroller. So in this part, you are going to put settings, and here the loop part, the main code. With the Arduino IDE installed and running, we can now pick up our Arduino and connect to the PC. Let us now focus on the hardware. What we have here, it's an Arduino compatible board that you can affordably find in most parts of the world. The design files are also open source, so you could make your own Arduino as well, but usually it is cheaper for you just to buy the board. The board is quite simple and has only the essentials. Even if you are new to electronics, you can still learn by just looking at it. So on the board here, on the bottom, we only have the routing traces that are part of the PCB wiring, and all the components are then here on the top. In the center, we got the most important part, the microcontroller, where we got the processor that it's going to run our program, the memory where the program it's going to be stored, and all the peripherals like the serial port controller and the ADC. Most of the pins of the chip are also connected to these headers on the top and on the bottom. You can see that on the top we got the digital ports, and then on the bottom we got both the power and the analog ports. On the right, there are some in-system programming pins that usually you don't need to use, as the board already comes prepared to be programmed by USB, thanks to a bootloader running already on the microcontroller. Then, here, on the left, we got a button that it's used for reset. Here, with the metal casing, we got an oscillator that it's used as a reference clock. Below, the serial to USB chip. Then, on the bottom, we got a circuitry used for the power supply. We also got the barrel jack for supply, but we will not use it. We are only going to use the USB port that also supplies the board with 5 volts. We can now go ahead and connect the USB cable, and then the board should be detected by our PC. Now, back on the PC, what we are going to do is you are going to go to your device manager, and then on the device manager, you go for ports, and then there is a couple of ports. On my case, I got a couple connected to Bluetooth, but you will check that there is an USB to serial COM port. This is the one that we want to use. In my case, it's COM12. So what I'm going to do is I'm going to get back to Arduino IDE, Tools, and then Ports and COM12. Also, you are going to select your board here, Arduino, and on my case, it's an Arduino Uno. And let's then program our Arduino. We are going to program on C. There is already a couple of libraries available. One of those is the serial library that I'm going to use to set up my serial port. With the serial.begin, and then you need to put the baud rate. I'm going to use the default 150,200 bits per second. It's C, so I need to close it up. And then on my main loop, I'm going also to print using my library serial with the function print_len. And then I'm going to use the function that is available by default called analog read. I'm going to use the first part that, let me check. It's a 0, the first analog part on my Arduino. And then, as I've said before, I'm supplying to the Arduino 5 volts, so I'm going to multiply the value by 5, and then, as the values that the ADC reads are in 10 bits, I'm going to divide by 1023. Okay, I can close this. And then after reading the value that I got on my ADC and printing to the serial port, I'm going to wait a bit. So it could be, for example, 200 milliseconds. This means that I'm going to have 5 values every second. And then I'm going to do this again. It's part of the loop. So this is my program. I try to do it as simple as possible, but is functional. So let's save it and program. Let's call it tutorial. And in order for you to program, you just click here on upload. Okay, it's done. So we can now check the result. For that, I'm going to click on tools and then serial monitor. The serial monitor, it's going to display everything that is being received right now. So it seems to be working. I'm receiving a value that is between 0 and 5. Right now it's just noise. What I'm going to do is connect the A0 analog pin to one of the voltage references that we got on the board. So what I'm going to do now is I'm going to pick up a jump wire and I'm going to connect that to the analog port A0. And then I'm going to switch between ground, 5 volts and 3.3 volts. Then back at the Arduino IDE, what I can see is that I now got 3.3 volts here printing on the console. If I change to 5 volts, then I got 5, and then the ground should give me 0 volts as expected. Okay, now the data is coming from the Arduino through the USB to a virtual serial port on my PC. And what I can do now is I'm going to use Julia with the library's libserial port in order for me to read data from the serial port on my PC. And then I'm going to pick up that data and create a graph using the library plots. Okay, so in order for me to check which port should I read from, I can use the command libserial port list ports. So let's give it a look. It's this one, COM12, the USB serial. This is the one that the Arduino is using. So let's create a variable called port name with my COM port and then the baud rate that I have previously defined on the microcontroller. Okay, perfect. So using those two variables, I can now open the connection using the command libserial port open with the port name and the baud rate. So the serial port, it's now opened and I can now read the data coming from there. Let's first create an array where we are going to save the data and our main loop to get the data from the serial port. So let's create a loop here. It can be a while true. It's enough for this example. And if there is any data, so if there is any byte available on the serial port, if this value is higher than 0, I can read that data and save it as a string. Read from the COM port. Now, why I'm using the string function here? Because if I read directly from the COM port, I can show you that I'm going to get binary data. So I already know that I'm sending through the Arduino ASCII characters, so I can just pick it up and say that I'm reading a string with my values. In this case, 3.33 volts. That's the value that I've defined there on my analog port coming from the ADC. And let's get that data and parse it as a float. In order to do that, I'm going to use the function parse as a float. And I need to split this string based on what? Based on this /r/n, so this new line. So for that, I can use the function split. Split, now it's correct. And I want to split based on this new line. If there is any value that is empty, usually more on the beginning or on the end, I can just remove it by writing keep empty equal to false. Okay, so let's give it a look, see if I did everything correctly. I did. So you can check here that I got a vector of floats with the values that I was expecting, that is those 3.33 volts. Now I pick up this data and I'm going to add to my array using the function append data array, and I'm going to add the comp values. And well, I can already plot. Let's plot it. Plot the data array. And as we are in the middle of a loop, if I write the plot will not appear. So I need to use the function display. Otherwise, on the middle of the loop, it doesn't work. But if I write display, then it should. Okay. And the if, and then I don't need to be constantly running this. I can sleep for at least 200 milliseconds. That's the delay that I also added on the microcontroller. And I think it's everything. So let's give it a look and see if it is working. Okay, so here we got our plot with around 3.33 volts. If I change the port from 3.33 to, for example, 5 volts, let's give it a look. As you can see, now I'm getting data here on the 5 volts. And if I change to the ground, I should have 0 volts. As expected. Okay, so the data is being received corrected on the Julia code, and I can now create something similar on a web page. So the next step is going to be to develop a website on Genie Builder. I have a video that is more focused on that, but easily enough, what you need to do is go here to extensions, search for Genie Builder, give it a quick search, then it should be the first here. Currently, I have it installed, but if you don't, there is an install button over here that you can click and it's ready to go. So after the installation, you just need to go to the Explorer, and then you are going to have two different tabs here, Genie Apps and Genie Server. I'm going to start the server. Okay, so the Genie Builder server, it's now running. We can go over here and click on Create Your First App, and let's call it Arduino. So app is created. We can click over here on Start App. Let's do it. And this is the Genie Builder GUI. So very simply, we got here an example. We already have a server running on the local host on this port over here. And for our example, we can clean the default elements that are here. And let's give it a title. This will be an web oscilloscope. And then I need not to generate random numbers, but I'm going to need to add a plot. So here on the right, we got the layout elements. I created a div, and I'm going to put there a line plot. Okay, on the line plot, there is some edits that I need to do here, and it's these two properties over here. So the data will be coming from a variable called plot data, and the layout of the plot will be coming from the variable layout as well. Okay, and this is pretty much it from the front end. Now, on the back end, we can go over here on the left and click on app.julia, and this is where the backend code runs, and the changes are going to be the following. First, we need to also import this libserial port library. This code is no longer used. Well, design is no longer used. Message also not. Private also not. So what we are going to have is going to be first my plot data for the plot, that variable that I have defined earlier. It's going to be of the type plot data. Then there is also going to be that layout from the plot. Plot layout. And I can already define how it's going to look. It's going to be a label for the x-axis. that is going to be called sample number. Yeah. So it's a number of the sample that we are getting. And then the other axis is going to be the y axis. And it's going to be called the voltage in volts. Okay, that's it. Then I'm also going to create a variable that is going to be used to update that plot. I'm going to call it update, and it's going to be a boolean. So by default it's false, and then I'm going to change to true and false again. Also, the variables related to the serial port, it's the same that we have done before, so I can even copy. So the port name and the baud rate, and also open it. So we can copy this over here. So I'm going to want to update this plot every second in order to avoid to use a lot of resources from my PC. So as soon as the website is ready, we can do that. I'm going to create an async task for that. And while true, the variable update, it's going to change between false and true. And this will happen every second. Okay, so this is going to be the variable that's going to define my update rate here on the graph. The rest, it's not needed. The next on change element, it's going to be the update. So as soon as the update is changed, so every second, I'm going to read the data from the serial port. For that, I can easily also copy the code that we got here as well. Now, the part of the plot, it's no longer needed, because instead of me plotting on this on change, I'm going to add to the plot data this new data. The type is going to be type plot data. The x, it's going to be a vector with the length of the vector itself, array. And then on the y, I'm going to get my voltage that is going to be saved on the data array. And you know what? I think this is all that I need to change for this GUI to work. So we can quickly save this and let's open the web page. So in order for us to open the web page, we can go over here to get, right click and open internet browser. And you know what? It seems like it's working. Let me change the pin here. So currently it's on ground. If I change to 5 volts, I got 5 volts. And if I change again to 3.3, I also got 3.3. And that's it, actually. So the web page is working. Hope you liked the tutorial. This is a great example if you want to interact Julia with embedded systems. And hopefully this was helpful to you. I'll see you again on the next tutorial.